Welcome to this Information Framework Fundamentals course. You may also hear others refer to the framework as the SID, an acronym for Shared Information and Data Model. Let's take a look at what the course has in store for you.
At the end of this course, you will be able to describe the role of information and data framework in modeling any aspect of corporate information. State the importance of consistent terminology in streamlining and accelerating projects. Relate how the information framework eases the ability to bring offerings to market due to flexibility of a common information model.
The course is made up of 5 modules. There's a set of elements within each module. Each element is meant to be viewed in its entirety without pause. Each module has a single learning objective for you. Beginning with Module 1, which introduces you to the framework, followed by Module 2, in which you'll learn how the framework is structured. In the third module, you'll understand the importance and use of modelling patterns. The fourth module, you'll apply extension guidelines. And finally, in Module 5, you'll measure conformance to the framework.
The key learning objectives of this course are to describe the role of information and data framework in modeling any aspect of corporate information. State the importance of consistent terminology in streamlining and accelerating projects. Relate how the information framework eases the ability to bring offerings to market due to flexibility of a common information model. At the end of this module, you will be able to describe the purpose and reasons for the implementation of the information framework. State goals that can be achieved by using the framework.
The information framework, highlighted here, describes the structure of business entities, which are things of interest to a business, such as customers, orders, resources, and so forth. The information framework, in combination with the business process framework, offer a way to explain how things are intended to fit together to meet a given business need. The business process framework defines the appropriate business processes, and the information framework adds definitions of information entities acted on and used by the processes, thus providing a means for capturing the structure and the expected behaviour of the proposed solution. Let's take a look at 5 common questions that help explain what the framework is. There are a number of goals that can be achieved by using the framework. Now we'll look at how a TM Forum member has used the framework to achieve some of the goals that were just explained.
Howdy. I was fortunate to witness the birth of the information framework and to see it grow into a healthy and still relevant teenager. And I've had the pleasure to tour the world, teaching members about it and seeing them use it. I would like to share to which it is put, and to which you may want to put it. Along the way, I'll provide a bit of guidance on how to quantify its value in reducing operating expenses, commonly referred to as OPEX. We'll take a look at 4 common uses of the framework shown here, and the effort and/or cost that can be saved associated with each one. First, let's look at the framework's use as a source of common terminology. One member did not have a common set of terms, such as one for customer, product offering, and service. As a result, everyone had their own term with its own definition, and spent tens of thousands of hours each year translating terminology during meetings, both internally and externally with collaborating parties who directly or indirectly provided value to customers. Apply an hourly cost figure to say 20,000 hours and you will be surprised. And these hours did not include the cost of problems associated with mistranslations. Next up is a framework's use as a starting point for an information model. The framework's development has covered about 14 years. It conservatively represents at least 50 person-years of effort and includes a collective subject matter knowledge of hundreds of members. What is the cost of 50 person-years of effort to your business? What is the opportunity cost lost to develop such a model from scratch? And the model continues to be enhanced to support new technologies such as network function virtualization, or NFV. What about the framework's use to facilitate application integration? This common use of the framework is also an OpEx reducer. I've seen members spend anywhere from 5 to 10 or more person-years, depending on the size of the integration effort, mapping proprietary interfaces to one another, or to a proprietary model residing in an application integration framework. And the interfaces and models were often lacking documentation. Here's where the use of the framework shines. The framework can also be used as a starting point for database and interface development. Without an information model to use in this way, each database is typically designed from scratch. To use it again for another database technology often requires a major restructuring of it. And often the same concepts are modeled quite differently, rather than having a common base, such as two totally different views of a customer or partner. This use is a bit of a challenge to quantify in general terms, but often the cost of repeatedly reinventing the wheel in different ways can run into many person-years of effort. One thing I learned quite some time ago was that every unit of currency saved in OpEx, whether it be euros, dollars, yen, and such, is a unit that can increase profitability. We've looked at 4 common uses of the framework and how they can reduce OpEx. But there are many more, which are part of what I call the SID Baker's Dozen Plus. Here they are. And there certainly are more, such as harmonizing industry models, using the SID with other framework components, and standardizing conformance. Until next time, see ya!
The key learning objectives of this module are to describe the purpose and reasons for the implementation of the information framework. State goals that can be achieved by using the framework.
In this module, you'll learn about the 3 key framework concepts from the bottom up, followed by a view of the framework from the top down. Then a case study that describes how to use the structure of the framework to define the boundaries or scope of a project.
At the end of this module, you will be able to describe the structure of the information framework, explain the difference between the horizontal domains and the vertical groupings, express the key idea of the structure of an aggregate business entity, ABE.
Here we'll look at three key framework concepts that are used in its structure and used to structure the model. First, we'll look at the structure of an aggregate business entity, often referred to as an ABE. The structure of an ABE begins with the first key concept called a business entity, or entity for short, which is something of interest to the business. Here's an example of a customer business entity. Business entities may be tangible things such as customer, active things such as customer order, or conceptual things such as a customer account. Business entities are characterized by attributes and participate in relationships with other business entities. Business entities typically move through a well-defined life cycle. There are many entities that define what a customer is, such as customer account contact, and customer credit profile. These three entities are closely related to the customer entity and depend upon it. This group, composed of the customer entity and its dependent entities, is called an aggregate business entity, or ABE. The second key concept used in the framework structure. An ABE is a well-defined set of information that characterize a highly cohesive, because of the dependencies, set of entities loosely coupled via associations with entities in other ABEs. For example, the entities that are contained within a customer order ABE, entities such as customer, are referred to as core entities because of the dependencies of the other entities upon it within the ABE. The ABE's name is often the same as the core entity. Here we've shown how the customer ABE was developed, starting with a single entity and growing to a collection of closely related cohesive entities that make up the ABE. This is often the way ABEs are developed. Many people think the framework was developed from the top down, but this is not always the case. The third key concept, called a domain, is a collection of aggregate business entities associated with a specific management area. Domains that make up the framework are consistent with the key domains and concepts in the business process framework and the application framework. Shown here is the entire customer domain, made up of a set of level 1 ABEs that completely describe all the information about customers depending on their complexity. Some ABEs may be decomposed into lower level ABEs, which you will see shortly. Shown here are the information framework domains. They're aligned with the domains that make up the top-level structure of the other frameworks. You may wonder how this domain structure was developed. The initial structure of the framework is based on previous work of another team, together with analysis that was performed on an enterprise-wide information model. This work included an object-oriented framework upon which the information framework is based. Development of the framework including performing affinity analysis on an enterprise-wide information model. Affinity analysis measures the degree to which entities are related and how they're used by processes, and resulted in both the domain structure and the definition of many of the aggregate business entities. Click on each domain to hear an explanation of its scope and contents. Make sure you review them all. Market sales. This domain supports the sales and marketing activities needed to gain business from customers and potential customers. On the sales side, this includes sales contacts, leads, prospects, through to the sales force and sales statistics. The market aspects include market strategy and plans, market segments, competitors and their products, through to campaign formulation. Customer. This domain represents individuals or organisations that obtain products from an enterprise, such as a service provider. It represents all types of contact with the customer, the management of the relationship and the administration of customer data. The customer domain also includes customer bills for products, collection of payment, overdue accounts, and the billing inquiries and adjustments made as a result of those inquiries. Product. This domain is concerned with the life cycle of products and information related to those products' life cycles. It includes the strategic portfolio plans, products offered, product performance, product usage, as well as the product instances delivered to the customers. Service. This domain consists of information used to manage the definition, development and operational aspects of services provided by an enterprise. Service supports various business process framework processes that deal with the definition, development and management of services used to realise products offered by an enterprise. This includes agreement on service levels to be offered, deployment and configuration of services, management of problems in service installation, deployment, usage or performance, and quality analysis. Service also supports planning for future services, service enhancement or retirement, and capacity. Resource. This domain consists of information used to manage the definition, development and operational aspects of networks, computing and application resources that enable products to be realised. It supports the business process framework processes that deal with the definition, development and management of infrastructure of an enterprise. Resources also provides usage information which is subsequently aggregated to the customer level for billing purposes. It also enables strategy and planning processes to be defined.
Business partner.
This domain includes all data associated with individuals or organisations that are of interest to an enterprise. It represents all types of contact with the party, the management of the relationship and the administration of party data. The engaged party domain also includes data and contract operations related to the party bills for products, collection of payment, overdue accounts, and the billing inquiries and adjustments made as a result of inquiries.
Formally engaged party, prior to our 19.5.
Enterprise. This domain represents information necessary to support the overall business, corporation or firm, such as human resources and financial and asset management. Shown here is the Information Framework's Level 1 ABEs within each domain, together with some examples of the content of different ABEs. The cell phone represents the information associated with product offerings available to prospects and customers. A shopping cart represents a customer order. An unhappy device that may have service problems. A computer network represents a collection of resources, and individuals and organisations represent parties with whom an enterprise interacts as it conducts its business. We'll look at this level of the information framework in more detail next. Shown here are the Information Framework's Level 1 ABEs within each domain. First, let's go over the legend below the framework. Not fully developed status for an ABE or an object means that it is an empty or almost empty, but it has been identified as required. Development is based on member contributions and none have yet been made for these ABEs. Preliminary status is typical work that is delivered over a series of iterations. A SID ABE or any object with a preliminary status is usable as it is, but a deeper study is in progress to complete the content of it. Some modifications might be made. Note that even if a primary object is approved by the framework team and the TM Forum, it won't be included in TM Forum conformance certification as it has to be complete. You may wonder how the ABEs were identified. Referring back to what affinity analysis measures, a direct relationship between these ABEs and process framework first level core processes can be seen if you've taken the Business Process Framework Fundamentals course. Whether you have or not, here are some examples. Customer order entities, contained with the customer order ABE, are the focus of the order handling process. Service is the focus of the service configuration and activation process. Service performance is the focus of the service quality management process. Additional details about this relationship will be presented in a later module of this course. You'll be given an opportunity to learn more about each Level 1 ABE later when you work on this module's exercise. The decomposition of information may continue to a second and further levels depending on the complexity of the Level 1 ABE. This is shown next. We'll also look at some ABEs in more detail during our tour of the frameworks model in the next module. Shown here is a sample of the next level of decomposition from the market sales domain. For example, the competitor ABE contains competitor entities along with two other ABEs as shown. Next up is a case study that shows common use of the information framework's domain and ABE structure. In this case, its use will be shown within the TM Forum's Conformance Certification Programme. We'll look at conformance to the information framework model in more detail in a later module of this course. Shown here is the homepage for the Conformance Certification Programme. We'll take a look at how the scope or boundaries of one company's certification was specified in terms of domain and ABEs. You can also see here the importance placed on conformance by enterprises seeking products and solutions from other companies, such as software vendors. Here is an earlier release of the framework to which a vendor's product was certified. A good practice when defining scope is to start with domains, including those in scope and those out of scope. For example, the scope of this conformance assessment project includes all domains except for supplier, partner and enterprise. And because of the domain-based structure, you don't have to worry about looking at the entire model to find all the ABEs that are related to some key concept such as customer. They're all contained in the customer domain. The next step is to include all the level 1 ABEs that are within the scope of the project, as shown by the ABEs enclosed in blue rectangles. Here again, you don't have to look through the entire product domain to ensure that entities that define an offering to the market are included. They're all contained in the product offering ABE. Subsequent steps look at the lower level ABEs to determine if they're within the scope. As a last step, you may want to include the entity's attributes associations within each lowest level ABE that are needed to satisfy a project's information requirements. When in doubt about a domain or level 1 ABE's definition, you can always consult the Information Framework poster, available on the Information Framework web pages, or the Core Frameworks Concepts and Principles GB 991 document that contains their definitions. Definitions of some level 2 ABEs are included in the poster, and the model is being updated to ensure that definitions of all ABEs are included. That wraps up the case study. Let's move on to the next element.
The key learning objectives of this module are to describe the structure of the information framework, explain the difference between the horizontal domains and the vertical groupings, express the key idea of the structure of an aggregate business entity, ABE. At the end of this module, you will be able to describe how unified modeling language is a way of expressing information models. Explain the needs and the benefits of using modeling patterns for the information framework. State the differing modeling patterns that have been used to develop the framework's model.
This part of the course provides a short tutorial on the Unified Modelling Language, or UML, used in the Information Framework Model. For those not familiar with UML, it will provide you with a sufficient knowledge to understand the UML representation of each pattern used in the model and for the model in general. Here is the scenario that will be used to show how UML is used to model key information framework concepts such as entities, relationships between entities, attributes and types of entities. Let's take a look at them. The class diagram has already been added along with the shopper and shopping cart entities from the scenario, represented as UML classes. You can see here how their names follow the UML naming standard, which is to capitalize the first letter in each word and not to have spaces between words. One of the other two compartments in each class holds attributes or facts that further describe each entity. I'll add 2 attributes to the shopping cart entity. The third compartment holds operations or methods which represent behaviour associated with the entity. Remember that the information framework model does not contain operations. These are specified during interface API development by work groups developing them and are kept in a separate implementation model. I'll add a checkout shopping cart operation. The UML naming standard for naming for attributes and operations is followed in the model as shown here. The first word in the name starts with a lowercase letter. All subsequent words start with a capital letter. There are no spaces between the words. You may wonder what the closed parentheses are that follow the operation name. These are used to specify parameters that are input to or output from the operation. None are shown here. Associations, sometimes referred to as relationships, are used to represent the business associations between entities. Associations can often be discovered by looking for phrases that are used to describe the entities or in the description of processes or use cases that involve the entities. For example, a use case may include the phrase, "A shopper uses a shopping cart to make their purchases." I'll add this association to the model. You can see the UML standard that the first letter of each word in the name of the association begins with a capital letter and there are no spaces between words has been followed. The modelling guideline used in the information framework for naming associations is also shown here. The name should begin with the name of one of the related entities followed by an active verb, and all associations should be named. The multiplicities or cardinalities in an association represent rules that specify how many instances of the entity can be related to each other, and they define what rules the multiplicities imply. For example, in this scenario, a shopper does not have to use any shopping cart once they're signed up on the website, and can exit the site without using a shopping cart. This is represented by an asterisk, or star, which means 0 to an unspecified number of shopping carts can be used by a shopper. The 0 means that the shopper does not have to have any related. I'll add this to the association. If the multiplicity was 1, star, then the shopper would have to start shopping before exiting the site, or the information about the shopper would be lost, hopefully with the site providing a warning message that this is about to happen. Also, the 1 multiplicity for the shopper means that a shopping cart can only be associated with one shopper, implying that a cart cannot be shared. Lastly, UML subclasses are used to represent types of entities. Subclasses are used to represent additional attributes, associations and/or operations that are unique to certain types of entities. They also inherit the attributes, associations and operations of the entity, in this case shopper, so they do not have to be added for each subclass. In the scenario, a business type of shopper has a business rewards account number that describes it, but a personal shopper does not. I'll add the business shopper subclass to the diagram. The generalization association means that the business shopper is a type of shopper. Next, I'll add the rewards account number attribute. I'll also add a personal shopper subclass to show that there are two types of shoppers. The naming standard for subclasses is the same as for naming classes. Now you should be able to read just about any class diagram in the model. Now we're going to take a look at the 5 modelling patterns that are used in the Information Framework model. We'll start by explaining what a pattern is and the benefits of using patterns. Then we'll look at each pattern, first from a business requirements perspective and then from a modelling perspective. What are information modelling patterns and the benefits of their use? You may be familiar with software design patterns. Information modelling patterns are used in a similar way. An information modelling pattern is an information structure that can be applied repeatedly to model commonly occurring information requirements. There are a number of benefits to employing modelling patterns as shown here. There are quite a few patterns contained in a number of books and papers that could be used to model information, probably at least 50. Using a small number makes the model consistent and much easier to understand. You only have to learn about the 5 used. Using patterns represents a consistent approach to modelling rather than having no patterns at all. Similar business requirements would most likely be modelled differently, making the model harder to understand. How consistent and easy to understand would a model be that used 10 or more patterns? The patterns were also chosen to provide built-in extensibility, such as the ability to define almost any type of product, service or resource without making many changes to the model. However, their use is not restricted to the product, service and resource domains. As will be seen later in the course, the patterns should also be considered when extending the framework to meet enterprise-specific requirements or to model existing ABEs that have not yet been developed. Here we will look at a short summary of each pattern before diving into the detail of each. You can begin to imagine examples of business requirements you've experienced where one or more of the patterns could have been used. Entity specification entity. Many entities are described by specifications, which take the form of paper spec sheets or links to specifications that can be found when shopping on the web. The facts, attributes for a specification, such as weight, dimensions, colour and so forth, are common to all instances of the entity related to the specification. Composite atomic. Entities of the same type are often grouped together. For example, bundles of product offerings, network elements composed of physical and logical resources. Entity role. An entity can often play many roles while retaining a basic set of facts about the entity in general. For example, an individual can play the role of customer and employee, but the individual's name and address don't change from role to role. Business interaction. As an enterprise carries out its mission, it interacts with individuals and organisations in a number of ways. This generalisation pattern models the characteristics, entities, attributes and associations, common to most interactions. As such, it allows new interactions, such as customer orders, late payment notices and so forth, to be easily added to the information framework. Characteristic specification, characteristic value. Attempting to model every attribute for new and or existing entities or attributes associated with new types or specifications of entities is a near impossible task. This pattern enables new attributes to be dynamically defined, eliminating the need to explicitly model them. The first pattern we will look at is the entity specification entity pattern. The entity specification entity pattern is widely used in the information framework. Many process frameworks processes such as product and offer development and retirement, service development and retirement, and resource development and retirement focus on these entities. Its heavy use in the product, service and resource domains is evidenced by the fact that there are level 1 ABEs for each specification and entity in these domains. It's also used in many other areas of the information framework, such as customer bill and performance. Most entities have a specification. To quickly recap the entity specification entity pattern, many entities are described by specifications, which take the form of paper spec sheets or links to specifications that can be found when shopping on the web. The facts or attributes for a specification, such as weight, dimensions, colour and so forth, are common to all instances of the entity related to the specification. Shown here is an example of an entity specification, in this case a product specification from a website, that demonstrates the fact that this pattern exists in the real world. To support this in an information model, there should be a way to consistently represent this. As can be seen here, there is typically a tab or web page that describes the entity. Shown here is an instance of an entity, in this case a product that's been obtained by George and described by the specification for the router. An entity typically is described by more information than is provided by the specification of it. Here is the serial number and the customer who's obtained the entity. The example also illustrates there is a real-world need for an information model to support both a specification for an entity and an entity that is described by that specification. There is no need to repeat all the attributes that describe each entity, here a product. One way to think about this pattern is that the specification contains attributes such as model number that are shared by all instances of the entities described by the entity specification, and that the entity contains attributes unique to it, such as serial number. Before showing diagrams that contain examples from the information framework model, a few points need to be made about the diagrams that will be shown throughout this part of the course. These are general notes for all the UML class diagrams. The figures show a window into the model. As such, they only show a subset of the entities and associations within an ABE or group of ABEs in the figure. Rather than use instance diagrams, which is a UML diagram that shows instances of entities, callouts are superimposed on class diagrams to show instances of entities. The reason for this is that instance diagrams showing the volume of entity instances used in the examples would not be able to fit in a single figure. Because instance diagrams are not being used, instances of associations are only shown in the first figure. After this, they should be evident in the remaining figures. The generalized patterns you'll be shown here use entity as a placeholder for the actual name of an entity used when applying the pattern. For those of you familiar with UML, although all of you should be familiar with UML based on the UML overview section at this point, the generalized entity specification entity pattern is shown here. Two entities make up this pattern. The 0,1 component of the association may be changed to a 1 when the pattern is applied to meet a specific business requirement, if an entity must be associated with a specification. In some cases, such as in the resource domain, the resource specification for a resource that is discovered may not initially be. Multiplicity of the association would be retained for this application of the pattern. Here is an application of the pattern in UML from the product domain. The product specification entity contains attributes such as product number, name, description and brand that are shared by each instance of a product described by product specification. Notice that the generalized entity specification in the pattern was replaced by product specification and the generalized entity was replaced by the word product. Entity was also replaced in the name of the association with product specification. From the scenario, you can see that basic TV, the set-top box, the wireless router and so forth are instances of product specifications that describe the products acquired by customers. And from the scenario, you can see George's instances of the products which is acquired are described by the associated product specifications. Shown here are other applications of the entity specification entity pattern in other information framework model domains. All the patterns that will be discussed in this part of the course are applied throughout the information framework model, but this is the only example that will be shown in this part of the course. The next pattern is the composite atomic pattern. This is probably the most widely used pattern. It's often used together with the entity specification entity pattern. For example, if a specification is made up of other specifications, this pattern would be used, and the entities described by the specification are almost always grouped, necessitating another application of this pattern. This will be pointed out in a later case study in this part of the course. To quickly recap the composite atomic pattern, entities of the same type are often grouped together. For example, bundles of product offerings or network elements composed of physical and logical resources. Shown here is an example of the pattern from a provider's website offerings. The example here shows a bundle, FIOS double play, that delivers fibre optic offerings to a customer. It is composed of atomic represented by FIOS TV and FIOS Internet, as well as a DVR. Notice that the wireless router is included in the package, composite. For those students familiar with UML, the generalized composite atomic pattern is shown here. There are three entities that make up this pattern: the entity and two subclasses, composite entity and atomic entity. The composite is a type of entity used to group other entities. Either other composites, atomics, or a combination of composites and atomics. These varied groupings are supported because the association composite entity comprised of is inherited as shown. The atomic is the lowest level of the grouping. It can also stand on its own and not be part of any composite. The 0,1 multiplicity circled in red means that the composition can only represent a hierarchy or tree. An alternative to this is to make the multiplicity star 0,n to support a network type of composition where the same entity can be related to multiple composites. Shown here is the use of the pattern that describes a bundled offering to be defined. Note that the composite atomic entities in an application of this pattern do not have to contain the word composite or atomic in their name. It is more meaningful to use a business-oriented term, as in this example if possible. The IPTV service, bundled offered from the scenario, is comprised of four simple offerings as shown. The instances of the associations are not shown as noted previously in the entity specification entity pattern scenario. Shown here is the application of the pattern in the resource domain, where a compound resource is a composite of one or more other resources. It also shows another application of the pattern where a resource collection is a composite of other compound resources. For example, a server farm is the resource collection composed of servers which are compound resources. Next up is the entity-entity role pattern. It is primarily used in the common product, service and resource domains. Entities in these domains can play a number of roles. This pattern provides a means to include additional roles without major structural changes to the information framework model. Note that the first two patterns discussed to this point of the course support the concept of inherent or dynamic extensibility, while this pattern and the next one will support extensibility using subclassing or blade concept. To quickly recap the entity-entity role pattern, an entity can often play many roles while maintaining a basic set of facts about the entity in general. For example, an individual can play the role of customer and employee, but the individual's name and address don't change from role to role. Shown here is an individual, which is a type of party that can wear many hats or play many roles, as shown here. Another type of party is an organisation, which can also play many roles, such as that of customer, a supplier, partner, and so forth. Here are some other examples. A network element can play the role of a switch or a router, or a network can play the role of a distribution network or a core network, or an address associated with a customer order that can play the role of the installation address or the billing address. For those students familiar with UML, the generalized entity-entity role pattern is shown here. There are two entities in this pattern as shown. An entity can play 0, 1 or more roles. The multiplicities of the association typically do not change from one application of the pattern to another. To get started with the playing role pattern, here is the concept of a party that can either be an organisation or an individual that can play 0, 1 or more roles. From the scenario, George G is an instance of an individual and he is playing two roles, that of a customer and that of an employee. Next, we'll look at one example of the roles that a party can play. Often, roles played by parties are so important to an enterprise that they are represented by an ABE. Here, the entities that make up the customer ABE are shown, again with George G as an instance of a customer. Also shown is an instance of customer account for George G's American Express account that is used to pay for offerings George G obtains. George's home address is also shown. You may notice that customer account no longer contains any attributes. The addition of the engaged party domain created ABEs and entities that are similar to those in the customer domain. To minimize the amount of entity and attribute duplication, some entities were removed from the customer domain and attributes were removed from customer domain entities such as customer account. When attributes were removed, a composite association was used to indicate that an entity, such as customer account, is further defined by the similar party domain entity. George's home address is also shown. You may wonder where the details of a customer's address are kept. They're in the location ABE. You may also wonder where the names such as first, last and so forth are kept. They're in the party name entity and its two subclasses, individual name and organisation name. The reason for this is that there is no need to model these concepts over and over each time they are used. Next, we'll look at the fourth pattern, business interaction. A business interaction is the root of all entities that represent some form of request, response, notification, agreement or instruction. Entities, attributes and associations common to all types of interactions are inherited from business interaction. Some modelers would say that this is not a true pattern. However, it is and can be applied over and over again, hence why it's considered to be a pattern, to support the modelling of any type of interactions an enterprise has with one or more parties playing a role. There are a number of characteristics common to most business interactions, such as associations to locations, offerings, services, and so forth, and attributes such as an ID, the date of the interaction, the status, the date complete, and so forth. The requirement that implies the application of this pattern is that a new entity represents some form of interaction between the enterprise and one or more parties playing roles. To quickly recap the business interaction pattern, as an enterprise carries out its mission, it interacts with individuals and organisations in a number of ways. This generalisation pattern models the characteristics, entities, attributes and associations, common to most interactions. As such, it allows new interactions, such as customer orders, late payment notices and so forth, to be easily added to the information framework. What type of business interactions can you name? Shown here are examples of two types of business interactions that require personal information. The examples are personal information associated with a customer order and personal information associated with a rebate. Rather than model these twice, and many more times, this pattern provides a single representation of personal information for these and any type of interaction. Shown here is the first part of the pattern, showing the business interaction. Business interaction is an entire ABE, but only a subset of the entities contained within it are shown. There isn't a generalised pattern showing the placeholder entity as in the other patterns, because the various types of business interactions, such as customer order, inherit from business interaction. George's order is an instance of an interaction. Also note that the pattern supports the requirement that interactions can be related to one another, not shown in this diagram though. For example, a customer order can be related to an order acknowledgement that confirms the order. A customer order can be related to the service orders that configure and activate the services used to realise the products associated with the order. George's home address, shown by the business interaction location entity, which is related to place or location, is where the services will be installed. The relationship to place is not shown here. George's personal information is made available by the association from party interaction role to customer and its inherited relationship to party name. The account that will be billed for the order is available via the association from customer account interaction role to customer account, whose type attribute is bill to account. George's IPTV order is shown here as an example of a customer order. As was the case for party roles, such as customer, many types of business interactions, such as customer order, are an ABE within the information framework. Business interaction item and its subclass customer order item represent the offerings that make up the order, such as George's set-top box. You may wonder about the other types of customer orders, such as access service requests, shown here. These were added early in the development of the information framework model to demonstrate the blade or subclassing concept to support North American regulated orders. The fifth pattern is the characteristic specification characteristic value pattern. Some modelers call this the attribute pattern, since it is used to enable the dynamic addition of attributes that describe an entity without changing the model. It is used in many domains such as market, sales, product, service, resource, and has now been generalized as the Level 2 ABE in the Common Business Entities domain, Root Business Entities ABE. It is very useful in the product, service and resource domains, to name but a few, because often with the introduction of a new type, instance of a specification of product, service or resource, there are additional attributes or characteristics that represent properties and or features not supported by the current information framework model. For example, the number of ports available on George's wireless router that is being displayed as part of the offering. This pattern is often used with an entity specification entity and composite atomic patterns to enable near complete freedom, dynamic extensibility, in defining any type of entity or subclass and its attributes together with the various ways to group the entities. Use of the entity specification entity and characteristic specification characteristic value patterns together is often described as enabling dynamic subclassing of an entity or the dynamic object pattern. To recap the characteristic specification characteristic value pattern, attempting to model every attribute for new and or existing entities or attributes associated with new types or specifications of entities is a near impossible task. This pattern enables new attributes to be dynamically defined, eliminating the need to explicitly model them. We return to the previous example used in the entity specification entity pattern. There should be a modelling pattern that allows the properties of the wireless router shown here to be specified. These properties or features are often referred to as characteristics or attributes of an entity, such as the router offered in the scenario. In this example, characteristics include the technology, bands, USB support and so forth, as shown in the Specifications tab. The characteristic specification characteristic value pattern supports this requirement. It also supports the requirement that some of these properties are either fixed or configurable. In the example here, the properties are fixed. An upcoming example will show how they can be configured. For those students familiar with UML, the two key entities of the generalized characteristic specification characteristic value pattern are shown here. The characteristic specification defines the properties, while the characteristic value defines the value associated with the property for a specific entity. For example, the viewing date for a particular video. Like the business interaction pattern, this pattern is an entire ABE that can be reused when requirements imply its use. Other entities in the ABE represent the valid values that a characteristic can take on, groupings of characteristics similar to the composite atomic pattern, as well as entities that enable the reuse of characteristic specifications that two or more entities have in common. For example, the bandwidth associated with an offering and the bandwidth associated with a resource, or the colour of various smartphones and various wireless routers. Part of the scenario description that will be used to demonstrate the use of this pattern is repeated here for your convenience. There are two options that could be used to support the four VOD information requirements: category, title, format, start date and time. One option is to explicitly model this offer as a subclass of product, the blade pattern, but then the model has to be changed. A second option is to use the characteristic specification characteristic value pattern. We'll look at both options. Shown here is the first option for handling VOD information requirements using the blade concept by creating a subclass of product. Note that a change like this would have a substantial impact to the underlying database and application. Note that all these attributes are configurable by the customer, such as George. Attributes that are not configurable would be contained in a subclass of atomic product specification, which would have further impact on the database and application. Shown here is the use of the second option, which uses the characteristic specification characteristic value pattern. Here is the characteristic specification part of the pattern, represented by product spec characteristic. Next, we'll show you the characteristic value part of the pattern's application. By enabling attributes to be added dynamically, no changes need to be made to the underlying database or application. Note that a database and application would have to be enhanced to support this pattern though. The VOD instance of product specification from the scenario is shown here. The four attributes of VOD, category, title, format and start date and time, are shown as instances of product spec characteristic and associated to the VOD. The association is not explicitly shown here. The valid values that the attributes can take on are shown as instances of product spec characteristic value, such as high definition and standard format. Associations to the valid values are not shown, but implied by repeating the name of the attribute as a prefix to each valid value. This pattern can also be used to add attributes to entities that do not have an associated specification. For example, attributes could be added to customer or product specification. In the case of product specification, the attributes would apply to all instances of product specifications. This is the characteristic value part of the pattern's application, represented by product characteristic value. Shown here is a selection George has made as instances of product characteristic value for viewing of VOD. Note that any fixed, non-configurable product spec characteristic do not have to have an instance of product characteristic value. For example, there's no need to duplicate a weight value that doesn't change. From a database perspective, it may be desirable to have an instance to avoid navigating to the characteristic specification part of the database.
The key learning objective of this module are to describe how unified modeling language is a way of expressing information models. Explain the needs and the benefits of using modeling patterns for the information framework. State the differing modeling patterns that have been used to develop the framework's model.
In this part of the course, we'll look at how the framework is documented, the framework's relationship to the business process framework, and modelling extension guidelines. Then you'll see a case study that shows the application of the guidelines, and then you'll have an opportunity to test your knowledge by taking a quiz and completing an exercise.
At the end of this module, you will be able to identify how the information framework is documented. Discuss the information framework's relationship to the business process framework. Recall the modeling guidelines used in the model and that are recommended for use when extending the information framework.
Let's take a look at how the model is documented and the various formats in which the model is available. Shown here are the two sets of documents. Both sets are available on the Information Framework web pages. The first set helps anyone interested in the framework to get started. If you're not familiar with information modelling, the primer is a key document for you to read. The Concepts and Principles Guidebook, GB for Guidebook, 922 for this framework series of guidebooks, contains definitions of key concepts. The complete Level 1 structure with definitions of each domain and Level 1 ABE, as well as mappings to the business process framework. It has been consolidated into GB 991, which contains concepts and principles for the information framework, business process framework, and application framework. The user's guide contains much of the content of this module, as well as descriptions of the patterns you saw in the previous module. It is recommended that the documents in this set should be read in the sequence shown here. The first one is optional for those of you familiar with information modelling. The addenda in the second set are organised by domain to be consistent with the structure of the framework. With the exception of the common and resource domains, there's a single addendum for each domain. Each ABE in the Common Business Entities domain has its own addendum. The resource domain has an addendum for logical and compound resources and one for physical resources. There's also an annex of the logical and compound resource addendum that describes the computing and software level 3 ABE within the logical resource level 2 ABE. You may wonder why the word addendum is used. The reason is that these documents can be viewed as additional information about the model which resides in a UML tool. They're also referred to as guidebooks. You'll see what is inside a guidebook. Here is the title page that contains the release number and date. The IPR mode, RAND, means that the framework project is operating under an IPR mode of reasonable and non-discriminatory. Details for those interested can be found on the TM Forum website's Policy on Intellectual Property Rights Standards page. Each guidebook begins with an overview of the domain that you can see here. Here you can see a UML class diagram that shows the key entities along with their attributes and relationships among the entities in the product domain. Many guidebooks start with this type of overview diagram. Here's an explanation of the diagram which follows and/or precedes each one. Each aggregate business entity, or ABE, in the domain typically has its own section in a guidebook. Here's the one for the product specification ABE that begins with an introduction and explanation of the ABE. Here's an example of a product specification. Here is a UML class diagram that shows the key entities in the product specification ABE. One aspect of the model that's begun to be added to each guidebook is the rationale behind a chosen modelling option. When more than one option exists, the other options are presented. Here's a table containing references that list sources of the guidebook's content along with additional reading. Some guidebooks still contain a data dictionary that provides a definition of each entity and attribute. The data dictionaries are gradually being removed to eliminate the duplication with the definitions contained within the model. This guidebook's data dictionary has been removed. That wraps up a look at a typical guidebook. Now you can see the various formats of the Information Framework model available to you, which can be downloaded from the Information Framework webpage. While not a model, there's an Excel spreadsheet that shows the differences between the current release and the prior release. Each folder contains a single file. In this case, it's an Excel file. There's an Excel format of the model that you can download. For those that don't have a UML modelling tool, the model is also available in two HTML formats, PNG and GIF. These two formats provide what can be thought of as a read-only view of the SID UML model. If you use Eclipse-based open-source Papyrus UML tool, there's a Papyrus archive zip file that you can download. If you use IBM's Rational Rows Architect or RSA, there's an RSA archive zip file that you can download. To support the use of the framework in other tools, XML and UML2 formats are available. Most UML tools support these formats for import. Some tools, such as Enterprise Architect, will import the native RSA model file. Lastly, there's also a README first and release notes document provided. You may wonder about the relationship with the other frameworks. You've seen that the Information Framework, the Business Process Framework and the Application Framework all have domains in common. Here you'll learn more about the relationship with the Business Process Framework by seeing how they're mapped to each other. Here you'll learn more about the relationship with the Business Process Framework by seeing how they're mapped to each other. Here you can see the Consolidated Concepts and Principles Guidebook. This walkthrough will focus on the mappings between the Information Framework First Level Aggregate Business Entities and Business Process Framework or ETOM core processes, most of which are first level core processes. The mappings are organised by domain. The principles for mapping will be explained to you during this walkthrough. Shown here is the mapping between the Information Framework Customer Domains Level 1 ABEs and the ETOM Customer Domains core processes. You can also see the definition of the domain and the ABEs. The ETOM vertical column is the vertical process category for the primary process. The acronyms such as B and RM for Billing and Revenue Management and F for Fulfillment are explained in the Principles for Mapping section. A primary process, shown in the Primary Processes column, is a core process that manages the entire life cycle of the associated ABE's entities. In other words, it creates, reads, updates and deletes, the four are often called CRUD, the entities. This characteristic of a process is what's used in affinity analysis to cluster a group of entities into an ABE. There should only be one primary process, otherwise functionality is duplicated. A secondary process is one that typically only reads or uses the ABE's entities. In exceptional cases, a secondary process may update an ABE's entities, but care must be taken in doing so as this begins to bind the processes more closely with the ABE and its primary core process. Shown in the mapping tables are examples of secondary processes, not the complete list. So, how can these mappings be used? The mappings are used internal to the TM Forum teams to ensure the completeness and correctness of the process framework and the information framework. For example, there should be a primary process for each level 1 ABE. There should be only one primary process. There should be a task level process that supports each life cycle state of an entity. There should be a level 1 ABE for each first level core process, and so forth. Besides helping confirm the correctness and completeness, there are several other uses to which TM Forum members can put the mappings. Both the frameworks can be used to assist in defining the scope of a project. Together, they provide an industry standard method or language to define the scope in terms of both processes and the entities upon which the processes act and use. By defining the scope of a project independently in terms of each framework, mappings between the two can be used to confirm the project scope. A project scope is determined by first independently identifying the core processes and the ABEs that define the boundaries of the project. Then the mappings are used to check that all core processes and ABEs have been considered for inclusion. For example, if the core process product offer development and retirement is included, then the ABE product offering should be contained within the scope. If the product ABE is included in the scope, then order handling should be included in the scope. And the definition of the scope in terms of both can be used to control scope creep in terms of both processes and the entities upon which the processes act and used. It becomes very obvious when a new process and/or ABE enters into the boundaries of a project. The mappings can also be used to support impact analysis. For example, if a process changes, what entities could be impacted by this change and vice versa? Now we'll look at the modelling guidelines used in the model and that are recommended for use when extending the information framework model. You'll also see some guidelines that are specific to extensions you may make to the model in order to support your enterprise-specific information requirements. The guidelines include adding new ABEs, use of modelling patterns, placement of extensions, extending existing ABEs, association attribute naming guidelines, and general modelling guidelines. If you're not an information modeller, this element may not be of great interest to you. However, you should go through it so that you gain an understanding of the guidelines that exist and not necessarily the UML modelling shown that represents adherence to the guidelines. Before moving on to the specific modelling and extension guidelines, let's first discuss how the basic structure of the framework's model enables it to be easily extended. The information framework can be viewed as a framework of frameworks, where each domain and each ABE are smaller frameworks within the overall information framework. The reason they can be viewed this way is the fact that the entire framework is based on the results of affinity analysis. What this framework of frameworks enables is the ability to add domain or ABE-specific blades, similar to the concept of server blades that allow additional components to be added to the framework without major impact to the other areas of the framework. This is a necessary characteristic of an extensible information framework and its associated models. Shown here is an example of an IP detail record, or IPDR, usage entity blade being added to the resource usage entity in the resource usage ABE in the resource domain. Blades are typically added as a subclass to existing entities that represent a new type of entity. Here are some examples of adding new ABEs to the model. These are used in the information framework model and should be used in your implementation of it. A new level 1 ABE, such as product configuration, can be added to the product domain and has been added to the model. Lower level ABEs can be added to existing ABEs, such as product pricing algorithm, shown here, that is in the model. It's recommended that you apply the modelling guidelines, such as patterns described in the previous module of this course. and those to be described in this module when developing any new ABEs. Keep in mind that if you decide to add a new Level 1 ABE, there should be a corresponding first level core process in the business process framework. If not, you may have to add the core process that manages the life cycle of the ABE to your process framework implementation. Similar additions may be needed in your implementation of the application and integration framework. One thing that must be kept in mind is that all extensions that you make to the model should be kept in a separate folder for each ABE that you extend. If extensions are kept in the existing framework ABEs folder and a new version of the ABE is imported, the extensions will be lost. However, this may not be the case if the UML tool you are using supports merging models, which is outside the scope of this course. Naming conventions for folders should be developed and followed. The name shown in the figure is just an example. If developing an existing framework ABE whose folder is not in the model, the name of the ABE followed by ABE should be used for the folder name. Note that this folder name should also follow the folder extension naming guideline. Now let's look at techniques for adding attributes to your implementation of the model. We'll look at 3 techniques for adding attributes to existing framework entities. Here, the existing entity customer account is not subclassed. Therefore, the blade or subclassing concept can be used to add enterprise-specific attributes. The word extension does not have to be used to indicate that the new entity is an extension. Some guidelines should be chosen and consistently used. Many modelers add a 2 to 4 character prefix followed by an underscore. One thing to consider here is that if any subclasses are added to the framework for the entity being extended, another technique would have to be employed. The reason is that the added subclass would not inherit the attribute extensions. One of the next 2 techniques can be used if this occurs. However, the case where an existing entity is subclassed seldom occurs after it first appears in the framework's model. Here is the second technique. This technique is used when the entity to be extended is already subclassed. Here, the attributes are inherited via an association, often referred to as an is-a association, implying the extension is a type of service specification in this example. The composition type of association is used to indicate that the lifecycle of the framework entity and the entity containing the enterprise-specific attributes share the same lifecycle. Where the composition appears in the association is up to the modeler. Here, the composition is from the extension to the framework entity, implying the key entity is the extension. If the modeler wishes to keep the framework entity as the key entity, then the composition would be from the framework entity. Some modelers prefer to use an aggregation type of association, which is also acceptable. This is the most stable technique for adding attributes to an existing entity. The third technique can be employed when there are a large number of extensions to make. For example, one member add extensions to half the framework model entities, which would have increased the number of entities in the extended framework from about 1200 to 1800, increasing the apparent complexity of the model and making it more of a challenge to manage. The disadvantage of this technique is that version control would have to be manually performed if the UML tool does not support some form of model merge functionality. For example, if a new version of customer account is introduced in the framework, either the extensions would have to be re-added or the new framework attributes would have to be manually added. Most framework entities are stable from their initial introduction, so the disadvantage of this technique rarely comes into play. There's a fourth technique that can be used to add attributes. Do you know what it is? The answer is the characteristic specification characteristic pattern. Now let's look at guidelines for adding new entities to your implementation of the model. The techniques on this and the next slide provide guidelines for introducing new entities to existing ABEs. The first technique is quite simple, since attributes were added to an existing entity in an implementation using the first technique for adding attributes. The new entity can be directly related to the entity that holds the added attributes. This example also shows two subclasses of the added entity. This second technique is used when attributes have not been added to an existing entity. Here, the added entity can be directly associated to the existing information framework model entity. One thing that must be kept in mind is that the association should be kept in a folder that holds extensions to the framework. If not, and a new version of the customer ABE is imported, changes may be lost unless your UML tool provides some form of model merge functionality. Next, we'll look at a series of guidelines that are used in the information framework model and that should be used in your implementation of it. Association should follow the naming guideline shown here. The name of the association should start with the name of one of the entities involved in the association, followed by an active verb. These guidelines were created during the third release of the information framework. Therefore, you might find some associations in the model that do not follow this guideline, and other guidelines you'll see in this part of the course may not be followed for this reason. Today, all submitted information framework change requests must follow these guidelines. For your implementation, it's up to you to follow the guidelines or not. Sometimes following the first association naming guideline results in a duplicate name. If this occurs, then the naming convention shown here should be used. This convention adds the name of the other entity involved in the association following the active verb. Some modelers wonder why the naming convention shown here can't be used all the time, and just have one convention. A consensus of TM Forum members involved in the Development Information Framework model felt that the exception should not be the rule. Plus, following this convention does result in longer association names, which can lead to possible issues. For example, developers don't like long names, and some organisations have guidelines that limit the length of the name. Here are some examples of attribute naming guidelines that are followed in the model and that should be followed in your implementation of it. The example shown here is for a status attribute. If an attribute such as status has the same definition from entity to entity, then the name does not have to be qualified. Otherwise, it should be as shown here, where the two status attributes are qualified by a prefix. There are a few general modelling guidelines shown here. Each entity and attribute should have a description. Some modelers also describe association. That's up to the modeler. Multiple inheritance, where an entity represents a subclass of two or more other entities, is or should be used. Typically, there are other ways to model requirements that result in multiple inheritance, and some tools or other forms of representing the framework model, such as XML schema, don't support multiple inheritance. There are not many association classes in an information model. Attributes and other properties that further describe an association are usually found when analysing behaviour. This creates the association. The information framework model does not focus on behaviour. There are not a large number of association classes. Only binary associations, those involving two entities, are used. UML does not prevent three or more entities being involved in an association. Some tools don't support this. There are typically other ways to represent this type of association. For example, an entity can be added that is related to the others. Lastly, if a modeler is looking for documentation guidelines, the guidebook format used for the information framework addenda can be employed. If a contribution to the framework is being contemplated, then the contributor should consider using this format. Documentation should follow GB922 format and content. See GB922 user guidelines for rules. Next, we'll look at a case study that shows how a TM Forum project team used the modelling guidelines to develop extensions to the model. These were eventually added to the model. Shown here are the service design and deployment entities. Extensions are shown in dark blue borders. Note the use of extension guidelines for naming convention for entities, SM_, When these were added to the information framework model, the SM underscore was removed for entities that became part of it. Next is the naming convention for attributes, SD status, ST status, followed by naming convention for associations. And finally, adding attributes to existing entity technique 2, SM underscore service spec. In the information framework model, these attributes were implemented as an entity related to the service specification rather than becoming attributes of service specification. The reason is they were not applicable to all service specifications in general. Shown here are service activation entities. Extensions are shown in blue. You can see here the continued use of modelling and extension guidelines. Now it's time for a quiz before you take on an exercise to practice the knowledge you've just gained.
The key learning objective of this module are two. Identify how the information framework is documented. Discuss the information framework's relationship to the business process framework. Recall the modeling guidelines used in the model and that are recommended for use when extending the information framework.
In this final short part of the course, we'll look at what it means to be conformant, sometimes referred to as compliant, to the information framework model.
At the end of this module, you will be able to state the differences between compliance and conformance when related to the information framework. Explain the basic process to achieve information framework conformance.
There are no universal compliance or conformance criteria across all of the frameworks. Each uses slightly different criteria tailored to the nature of each framework. Compliance or conformance can be viewed as a continuum, ranging from compliance, as in the common use of the word as compliance to rules and regulations, measured through hard, rigorous tests, to conformance, where tests are softer and can be sometimes perceived as subjective. Compliance involves applying TM Forum provided tests on the actual implementations of TM Forum interfaces. The result is that an implementation passes or fails, so this is clearly very rigorous. Conformance to the information framework and business process framework is measured by assessing components of them and assigning a conformance score to each component. We'll look at the information framework conformance scoring system next. It is more rigorous than that for the business process framework, where the descriptions of an implementation's task-level process are assessed. As such, information framework model conformance is considered to be closer to compliance along the continuum. Information framework model conformance criteria were initially defined early, in about 2004, in the development of the framework, but they were not widely publicised. The term SID compliant is often used, but it itself is too general. It often results in the question conformant to what part of the framework? Well, the answer is that conformance is defined at the aggregate business entity or ABE level. In fact, conformance is measured at the lowest ABE level, as shown here for the product offering level 1 ABE and its level 2 ABEs. A 10-level scoring system is used, which measures the level of adoption, with 1 being the lowest and 10 being the highest. The details of how the score is calculated will be explained on the next screen. You may also see an older 7-level maturity score, with 1 being the lowest and 7 being the highest. The scoring system measures how closely a group of entities and attributes matches the entities and attributes contained within a lowest level information framework ABE. This can be assessed very objectively and is why conformance to this framework's model is considered to be less subjective than the conformance to the business process framework. Shown here are the scoring guidelines. Scoring is carried out from the top of the list of SID components downwards. Firstly, a score of 1 is assigned if the equivalent ABE exists. Then an additional 2 points are scored if the core entity is equivalent. Then the core entity required attributes are scored. If the equivalence is less than 50%, then scoring stops with a maximum score of 4, low or very low conformance. If core entity required attributes equivalence is over 50%, then dependent entities and optional attributes are assessed and scored using the weighting shown in the table. The scores for each component are added together to create the total score for the ABE. A score of 10 means that the ABE is fully conformant. It is important to note that conformance is about equivalence, which means that the names of the entities and attributes being assessed do not have to match those in the ABE. However, it's much better if the names used in the information framework are used, because this reduces the amount of effort needed to translate one term to another via some form of translation table. Note that associations are not explicitly considered, since it is assumed that the equivalent will be present in the model or interfaces that represent the ABE. Associations to entities outside of the ABE cannot be measured, as the entities in related ABEs may not be part of the conformance assessment.
The key learning objective of this module are two. State the differences between compliance and conformance when related to the information framework. Explain the basic process to achieve information framework conformance.